Hi, my name is Pracheth and welcome to my channel. So today I have with me this ESP8266 module. It's used in IoT projects. It's called ESP-12E or ESP-12F. It's found in many development boards like the Node MCU and VMOS D1 Mini. So what if you don't want to buy those development boards and work with this chip only? So you need to convert this into a DIP package, and how to do that I'm going to show you. So you need to solder this pads to this header pins, but you can see that the spacing between these pads, the spacing between these header pins is not same. So you cannot do that. So what we have to do is we need to solder copper wires on these pads. So this copper wires you will get from this electric cable. You need to remove its insulation. Inside it you will find this single core copper wires. So now let's solder these copper wires on these pads. So I've soldered copper wires to the pads. Now I have to solder the header pins according to this diagram. So as this IC has got 22 pins, I've divided 11 pins on the left hand side and 11 pins on the right hand side. So you need header pins connected to the breadboard like this. So all you need to do is place this on top of this such that each copper wire is in contact with the corresponding pin. So we'll do that and we'll come back. So in this way it has to be placed such that each copper wire is in contact with its pin. So I will now solder this copper wire on this header pins and I will come back. So I've soldered the copper wires on the header pins and I've trimmed the excess copper wire. As you can see, this is the final soldering result. And here you can see that due to excess heat, the plastic was melted. But these two pins are not shorted. And also the plastic is not melted to extent to break this part. So it's okay. So what I'm going to do next, I'm going to cut off this top part and I'm going to pour epoxy between the spaces so that it gives sturdiness to the structure. But before doing that, I'm going to check continuity between the pad and the pin. So let's do that. So this is the first pin to put the meter in continuity. Okay, like this. And check whether there is a continuity or not. So the continuity test is done and it's all okay. Now I'll cut this top part. Now I'm going to remove this from the breadboard. And now I'll make an epoxy solution and I will pour it in the spaces. So the epoxy has hardened and the DIP package is now ready. It looks like this, as you can see. So now I can fix this on a breadboard, make the circuit, or I can directly solder it on a perf board for my prototype project. So in my upcoming videos, I'm going to use this module to make new projects. So subscribe to my channel. Now let's proceed. Now let's make the peripheral circuit and upload a program in this chip. Let's see how to do that. So you need to make this circuit first. In addition to this, you also require AMS-1117 3.3 volts regulator. So this is AMS-1117 3.3 volts regulator module. It takes input 5 volts and give output 3.3 volts, which is fed to this chip. Because this chip works on 3.3 volts, if you give 5 volts, then this will be damaged. And you also require USB to TTL module. You must have seen this on my channel. Connects to the COM port, RX goes to TX, TX goes to RX, ground goes to ground. Now let's make this circuit on the breadboard. I've already made it. You have to make this. So now I will connect this, fix this on the breadboard, connect this USB to TTL module, TX to RX, RX to TX, ground to ground, and I will place this voltage regulator on the breadboard. I will give input 5 volts and output 3.3 volts will be fed to this chip. So while uploading the code, you make sure that GPIO 0 is connected to the ground, and once the uploading is done, you disconnect GPIO 0 from ground. You can keep it floating and then you hit the reset button, the code will start to run. So now let's open the Arduino IDE. So I've already typed a code to blink LED on GPIO 10. Now for those who have newly installed Arduino and don't have ESP8266 boards installed, you need to go to File, then you need to go to Preferences. Here you need to copy and paste one link in the additional board manager's URL. That link I've given in the description. You just paste that link here and click on OK. Now you need to go to Tools, Board, Board Manager, and here you need to search for ESP8266 and you need to install this package, ESP8266 Community version 3.1.2. To select the version, you have to hit on install. I've already installed it, so I'll close this. So once all the boards are installed, you need to click on Tools. Now go to Boards. Here you will find ESP8266 boards. Click on Generic ESP8266 module. So you have selected the board and you have to go to Tools and select the port on which you have connected the module. So now the port is selected and the board is also selected. So now we are ready to upload this code. I've connected LED on GPIO 10. I've assigned it as output, and in the loop I'm blinking it with a delay of 1 second. So let's upload this code. I'll hit on the upload button. The board is in the programming mode. So as the code is uploaded, now I will remove this board from programming mode and I will hit on the reset button. And you can see that the LED is blinking on GPIO 10 with a delay of 1 second. So in this way we saw how to convert this ESP8266 into a DIP package and upload a program to blink a LED. So this was the video. I hope you enjoyed and learned something new. Subscribe to my channel. Thanks for watching.